Okay, as we've seen here recently a number of times, we've got an equation that gives us a model of some sort of object that we're dealing with in the real world. In this case here, it's a tunnel with an upside down parabola. Okay, we've got the x squared and the negative. We're told to sketch a graph of this, but we don't know much about it. So, how tall is the tunnel at its highest point? Well, that's going to be the vertex. So we want to be able to find the vertex, so we're going to have to maneuver some things around here. And in so doing, we will we'll start by moving the 16 over. So I got a y plus 16 if that gets moved over yonder. And at the same time, in the same step, I'm going to take out the negative that's out in front of here. So I got a negative 1, and I'm going to leave room for a trinomial, three items here. X squared, I got a minus 10x, and I've got space to add something else here. Okay, I'm going to take that, b over 2 squared. Negative 10 divided by 2 is negative 5. If I square that, it's a 25. So that's a plus 25. If I put a plus 25 here, I'm not looking at the big picture. Plus 25 times negative 1 is going on this side. So I need to have a times negative 1 on that side as well. Okay, in reality, it looks like I've added 25, but because that's there, I've actually subtracted it. So I subtract it from both sides. Okay, over here then, this is really 16 minus 25. Okay, and the difference between 25 and 16 is only 9, so that's going to give me a negative 9, y minus 9. And then if I factor this, it's going to be an x minus 5 and an x minus 5, or x minus 5 squared. So the equation I'm looking for is going to be y equals negative 1, and I'll call it a 1. It could be a negative like I have here, minus x, or x minus 5 squared, and then plus 9. So the vertex is at 5, 9. And so the tunnel at its highest point, measured in inches, this is a small train. All right. Oh, model trains. Excellent. So I'll read the problem next time. Okay, 9 inches. So it's a 9-inch tunnel. How did I know it's the k value or the y value of the vertex? Okay, that makes it a little easier to graph, but there's also going to be some other stuff. It's asking about the 5 inches tall and 9 inches wide. Is this going to be wide enough, first of all, for that opening? And we know that it's curved, so a train might be, we'll have to deal with that. So I need to know a little bit more about this equation, specifically the x-intercepts. Okay, so I got a little bit more algebra to deal with before I start graphing it. If I can, to find a root, or to x-intercepts, I need to plug 0 in for y and solve the equation. So I'm going to plug in 0, but I'm also going to divide by both sides by a negative. That's going to change each of these signs. That's going to change this to an x squared, that to a minus 10x, and that to a plus 16. So we're looking for two numbers that multiply together to get 16, add together to get negative 10. Well, that would be a negative 8 and a negative 2. And because they're equal to 0, I've got two solutions, x equals 8 and x equals 2. Those are my roots. I have all I need now to really graph a pretty accurate and reliable graph. It's going to look like that. Very parabolic in nature. In terms of the spacing here, I know that this is at a positive 2 and that's a positive 8. Don't quote me on the distance between. I know there's a space there and it's probably not big enough, but it's going to do what we need it to do here. That point there is 5, 9. Okay, so right in between the 2 and the 8 is our 5, and right in, it's got this train in theory is going to straddle the middle of this. Okay, but the train measures 5 inches tall and 6 inches wide, so it's clearly tall enough if it were a pointy-topped train. But we got to kind of assume that it's somewhat of a boxy shape. But it's 6 inches wide, which means from here to here, if it's 6 inches wide, then it's really going to be scraping the edges on both sides. And knowing that, if it's a train that looks kind of like this, it doesn't look as though it's going to fit, because if this is 9, then that would be around 5, and therefore you've got this curved edge. This section here and here are not going to fit. So the answer is, will it fit through the opening? The answer is no, because it's a 6-inch wide train. Now, if it were a 5 inches wide, And 6 inches tall, it might be because it's narrow enough and it looks like the mouth of this is wide enough here, but clearly from 2 to 8, the width of the tunnel is only 6 at the base. So anything that's 6 wide, 6 inches wide is really not going to fit unless it's curved inward more than the tunnel. Okay.